All right, class, we're going to talk about how to solve quadratic functions. We already have these particular notes, page 40, in our interactive notebook. Hopefully, you've already read this page in our notebook for this quarter, page 40. Here, the first thing that you need to make sure that you do is read the problem, okay? Read the problem. Identify the question. That means find out what is it that they want. What part of the parabola do they want? What are they looking for? Are they looking for the minimum or the maximum point, which is the vertex? Are they looking for are they looking for your zeros? Those are really the only two things that they can ask you for is your minimum and maximum value or your zeros for the most part. You might be asked to do some other things with your minimum and maximum value or your height, but most often that's what they're going to ask you for. Establish which formula you're going to use or concept you're going to use to apply. If you're finding your zeros, then are you able to factor and set your factors equal to 0 to find your zeros? Are you going to use the quadratic equation? Are you going to type it in your calculator and find your zeros? So those are three ways in which you can actually find your zeros there, okay? And for your highest point or your lowest point, you could use the axis of symmetry and then substitute that x value into the equation to find your y value. Or you can, again, use your calculator to find your vertex, okay? Or your minimum and your maximum point. All right, these are the parts of the parabola that I was talking about. If it's most often in real life situations, you're going to have a downward parabola in most cases, and that is due to gravity. What comes up must come down. This is the shape that most objects, when you throw something up in the air or when a rocket launches or anything like that, it has a pattern. It has a U-shaped pattern because of gravity, okay? Because of gravity. And if it is a gravity problem, then you're going to be using that negative 16x squared, okay, there, which you saw in your other video or in the previous video from yesterday. All right, so let's look at this one. Same thing. Not often will you be using this for real life situations. There are not a lot of real life situations where the shape is a upward U. Most often you're going to use word problems dealing with the downward parabola. Okay, and then again, most often your x is going to be time, seconds, years, day. It's just going to be time. And your y is going to be your height in most of these problems. So let's do some word problems and knowing all of that. Okay, so the first one, it says that Jason jumped off the cliff into the ocean, okay, while vacationing with some of his friends. His height as the function of time can be modeled, and this is the equation right here, where t is the time in seconds, and h is going to be the height, which is measured in feet. All right, so how long, this is a how long, so that's x. How long did it take, because we're talking about time here, so we know that that's x, because x represents the seconds, for Jason to reach the maximum height. So your maximum height in this parabola, this is again a downward parabola because a is a negative number. We're looking for this value right here. Okay, this is the value that we're looking for. So we're gonna use our calculator, and my calculator happens to be on my phone. And you're gonna go to y equals, and you're gonna type this in. So this is negative 16 x, okay? And we square it, plus 16 x plus 480, okay? And with this calculator, which is the one that I suggested that you download because this one's so easy, you're just gonna press graph. Okay, so when you graph that, if yours didn't show up perfectly like this, you can adjust by just moving your screen. You see how I move my screen? Okay. I kind of went in and out and go back out again. Oops, sorry. It's hard to use. Ooh, let me do. I had it perfect the first time, and then I messed it up. I completely messed up my graph. There we go. All right, good deal. So now when we get our graph right, then we're gonna tap on the parts that we need. We need the maximum height. So the maximum height is up here. And so what you do is you slide it to where you see maximum height. Okay, if you can see it, it says maximum heights right here. That's what makes this so cool. So our maximum height, the answer is in the corner. The vertex amount is going to be that 0.5, comma 484. So your maximum height is y, which is 484. So that's your answer here. Your y is equal to 484 feet. This is your max height. Okay? And the height is your y value. All right? It says, what is the highest point that it can reach? Again, it's the ordered pair that they're asking for now. The highest point is going to be that negative, I'm sorry, not negative, 0.5, comma, 484. Okay? Jason hit the, it says hit the water after how many seconds? Okay, look, there are 2 zeros here. Okay, if it hit the water, that means that your y value, your height has to be at 0. You know that it's not going to be at 0 this way because you can't have 0 seconds. So the only value that's going to make sense are when your x values are positive. So you're looking for this 0 right here. So, and you'll see that the calculator says y is equal to 0 right here. So in the corner, this is where your answer is. It's going to be 6, 0. So it hits the ground, hits the water at 6 seconds. So x here is equal to 6 seconds. Okay? All right, so when we do this one, if a toy rocket is launched vertically upward from the ground level with an initial velocity, okay, this is the speed of 128 feet per second. Again, that's the speed. Then the height, h, after seconds, t seconds, is given with this equation right here. Okay, notice that there's no constant, so that means that your c value is going to be 0. So it starts from the ground and goes up, okay? All right, so what we're going to do, it says how long. Again, this is x, because we're dealing with seconds for time. That's how long. So it says for the rocket to return to the ground. So it starts at the ground, 0, because we can see that there's no c value here. The starting amount is missing, so your starting amount here is automatically going to be 0. It starts at the ground. So when does it hit the ground again? So what we're going to do, we're going to go back to our calculator. Our y equals, I'm going to clear the equation that's there and type the new equation in. That's going to be a negative 16. Again, remember that is gravity this negative 16, x squared, and then we got plus 128, x. Don't forget the x. All right, so when I graph this, okay, this is the graph that I get here. All right, so again, we see that it starts at the ground, and what we're looking for is the second time that it hits the ground, or it returns back to the ground. So I can click on that and you can see the answer in the corner. X is 8 seconds and Y is 0. So that's when it hits the ground. The height is 0. So we got 8 seconds here as our answer. Okay. It says, after how many seconds will the rocket be at 100? So this is when Y is 112 feet. What is my seconds, okay? What is my seconds? So what we could do is we could look at your table values to figure that out. So when you go to your table, we're going to look for when Y is 112. So the numbers, let's now use your down arrow. All right, 112, look. Right here, when Y is 112, X is 7. So at 7 seconds, that's how long it takes for it to get to a height of 112. So we got 7 seconds. X is equal to 7 seconds. Okay? How long will it take for the rocket to reach its maximum height? So again, it's a downward parabola because my A is a negative number. So we're looking for this value right here, okay? This is my max. We're looking for that value, okay? So we go back to our graph, all right? And the value that we're looking for is here. And that says max. You know it's max because it's going to say max. So your maximum value here is going to be is going to be 256, okay? So your Y value, or your height, is 256 feet. And how long did it take for it to get there? Is the seconds. It took 4 seconds for it to get there, okay? But what they asked for was this, okay? All right. Oh, how long? They did ask for how long. So in actuality, what they're asking for is this 4 seconds. Okay? The maximum height is what they asked for here. So Y is going to be 256. Okay? Feet. All right. So here, this one, it says a rocket is launched from atop a 101-foot cliff, the initial velocity. So this is the starting amount here, okay, because that's where it's launched from. And initial velocity is this speed here, okay? It says substitute the values in this vertical motion formula. This is a quadratic formula. This right here is going to be the gravity. So you got Y is equal to a negative 16, and we're going to use X because that's what we're going to type in our calculator. Instead of T, let's just use X squared. And our initial velocity, which is the speed, is next. That's our X term. That's a positive 116 feet. Okay, we're going to use X instead of T. And our starting amount, or our initial height, that's why they got 0 here, because it's your starting height, is going to be 101. So that's the equation that we're using, okay? It says use the quadratic formula to find how long the rocket will take to hit the ground after it launched, and then round to the nearest seconds. Okay, so they want you to use, instead of using the calculator, they want you to use the quadratic formula. So this is the quadratic formula here, which you should have somewhere written in your notes. So we're going to label our A. Our A here is equal to a -16. Our B is equal to 116. And our C is equal to 101. All right, so those are our values for our quadratic. For our quadratic equation, so we can use that for the quadratic formula. So we have to do this twice because remember with the quadratic function, there could be two X-intercepts because it's a U. So let's do, using this formula, let's do first plus and then let's do minus second, okay? Because you have to do it twice in this formula. So you have X is equal to, we got a negative, and our B is 116. So we got 16 for B. And we're going to do plus, and we got the square root, and our B again is 116. So we got 116 squared, and then we got minus 4 times our A is -16, and our C is 101. Okay, sorry to squeeze that in there. And then on the bottom is going to be 2 times -16. Okay, so now the second one, you have X is equal to, we have -116. Then we have minus this time. Instead of doing the plus, we're going to do the minus now. And you have the square root, B, which is 116. And we're going to square it. Then we got minus 4, -16 times 101. Okay? Divided by 2 times the -16. Okay? You use your order of operations to find the answer to both. I'm gonna have to cut it short because it's running. I got a minimum. I don't have as much time on these videos as I would like. So we're gonna go back to our graph. Clear what you have, okay? And we're gonna check it to make sure that it's right. Let me tell you what it should be. We got -16 X squared. Let's see here. Plus 116 X plus 101. And when we graph it, this is what that looks like. I'm not sure. Let me make sure. Done. 101. Okay. Yeah, that's right. All right, so now our X-intercepts, you should have one over here, which is this, and they want you to round to the nearest tenths place, so you should get a -0.8, about 0.8 squiggly lines. And then you should get a positive about 8.03, but they want you rounded to the nearest tenth, so it's going to be 8.0 about, okay? And so that's what you do in these particular problems there, okay? Let's see, real quickly with this one right here, because I think someone had a question about this one. You and your friend are hiking on the mountains. You climb the ledge. That is 20 feet above you. It says the height of the grappling hook is thrown. This is the equation there. So it says, what is the maximum height? So what you have to do is graph this equation to figure out what this is here, okay? And then see if it is high, if you climb this high enough, could you be able to throw it to reach here, okay? So negative 16 x squared minus 32 x plus 5. All right, so when you graph that, this is what you have. What do you want? 20. Okay, you see that? All right, so your, let me make sure, did I type that in right? Let's see. Yes, I did type that in right. All right. Okay, so they want this maximum height here is 20. So yes, that will be about what your answer is. Because if you climb it up to 20, you're almost at the top there. So the answer here would be yes, because the height here is about 20 anyway. So you'd only have maybe a foot or even half of, not quite a foot to actually throw it. So you would be good there. Since y is almost 20. Okay? All right.